So as of now, I guess we have solved some of the problems from the Thevenin Norton for the dependent independent sources. Okay, and I hope you are already till now aware. And that's the important topic. You will get a good chunk of questions from this portion in the quiz also. So that's why we are practicing more and more. So you already know. I already told you how to basically solve if you just have an independent source. So only independent source is pretty simple. You calculate R as R equivalent, considering all the independent source as 0, and VTH you calculate as V of open source, open circuit across whatever the load resistance where you have to calculate the VThevenin. Okay, so that is how you calculate if you just have an independent source. When you have both independent and dependent sources, then you calculate R as how, like, VDC upon IDC. VDC is the voltage across, uh, you can just think of as a voltage across the load terminal, okay, and the current through the load terminal. Or you can say, let's for example any circuit that you have, okay, and in this circuit, if this is the load resistance RL across which you have to calculate, you can just think of as what, you can just think of as voltage VDC. So how to solve this? But this method you can just use it whenever you have an independent or dependent. One method can be when you just take the DC as 1. Whenever you will take DC voltage VDC as 1 volt itself, what will happen? You can directly calculate the RTH by 1 upon. So whatever the value, yeah, that you will be getting for the current, okay, IDC. So you can just divide it with 1, like 1 upon IDC. That will also give you an idea. So there are other methods also to solve the VTH when you have a combination of independent and dependent source. One thing there in your mind, that you don't touch the dependent source. Okay, while calculating the RTH also, you don't do anything with the dependent source. Okay, you just independent source, you just put it as 0. Like for voltage, you just short circuit, and for a current source, you open the circuit. Okay, this is how you do it. And VTH, that's same. Like you calculate the voltage of open source. Okay, and open source means the current will be 0 across that circuit, okay, or across that from that load resistance, or in that circuit the current will be 0. Now only independent source, okay, so in those cases what happens, your voltage for sure will be 0, so V Thevenin will always be 0. Okay, if you are given a circuit where you don't have any independent source, okay, so all are dependent source only, then you can directly write the VTH. So the equivalent circuit that you will be making, in that equivalent circuit, the voltage V Thevenin will always be 0. Okay, you can get some RTH, but VTH will always be 0. Okay, and VTH you can calculate in the same way. Okay, VDC upon IDC, or you can just take VDC as 1 and then try to calculate the IDC. Okay, now you have added a voltage source itself. You can add a voltage source of 1 volt. Okay, in spite of VDC, you can just add a voltage source of 1 DC and then check how much current is passing, like going away or from that 1 volt that you have taken. Okay, that will be IDC, and whatever the value that you are able to calculate it, that's reciprocated, you'll get the value of the RTH. Okay, that can also be a one method, or you directly take it as a VDC and then check VDC upon IDC. That will also give you the value of RTH. Okay, so this, as of now, this must be clear to you. Okay, so we have done for some of the cases that we were not dealing with any phases and all. Okay, yeah, this session is live stream. Okay, so now in this case you can see that we have some inductors also apart from the resistor. Okay, now how will you do this? The same approach you will be doing. You don't have to do anything different here also, as you have to calculate the V Thevenin. So you have to make a equivalent circuit, okay, equivalent to whatever the circuit that you have been given. And what you have to do is V Thevenin you have to calculate across AB. Okay. So if you have to calculate, so see, just by looking itself, you can see that this circuit is pretty simple. Just if you just look at it, seems to be very difficult. But if you have to calculate the V Thevenin, then you can see that what will happen across in this circuit, the other one where I2 is written in that loop, will there be any current? As you have to calculate V Thevenin, right? V Thevenin is what? V of open circuit, right? You just open this circuit across AB. Now, is there any current in the circuit?
No, sir.
No,
No,
sir.
right? Yeah. So if you don't have any current in the circuit, right? Now that means what? You're just left with one circuit. Okay. So how will you calculate the V, the voltage of the open source? So voltage of the open source will be what? V, shall just V of AB or V of open source or V Thevenin will be what? Will be equals to 10 VLI, VL1, correct? What is this VL1? VL1 is what? Voltage across which one? Okay,
Dependent
I
source.
just missed out. I just missed out. Let me check it. So VL1 will be the voltage across. I guess you can just take it as 3 ohm, or let's take it as this one. VL1 is the voltage across your inductor. Okay. So now you have to calculate what V Thevenin you have to calculate, and V Thevenin across this A, like this load resistance. As you know, you calculate the voltage, open circuit voltage. So the current in this circuit will become zero, and as the circuit will be, the current will become zero. So you don't have to calculate any drop across any of the resistor or inductor. Now you know that the whole voltage VAB will be same as here also. So here the voltage difference is was 10 times VL1. So L1 you can just think of as the volt. VL1 is what? The voltage across this inductor. Okay, now what you have to calculate? The voltage across this inductor. Now you have been given the voltage here. Now with the voltage divider rule you can calculate the voltage across this inductor, correct?
Yes, sir.
Right? So how will you calculate? Let's so solution. If you have to calculate, you just write it in the form of in the so 100 53.1. Now you have to calculate the voltage across this. So how do you do? Whatever J times 4 ohm upon 3 ohm plus J times 4 ohm. Okay, this will be the voltage across this inductor. Okay, this you can solve it 100 53.13. This also you can write it in the form of a polar J 4 ohm. If you will write it in polar, that will be what? The magnitude will be 5 and the angle will be tan inverse 4 upon 3. I guess that is also 53.13. Okay, so you'll be left with what? 5 you can cancel. Okay, how much? 20. So you'll be left with 80 times this angle. Also generally angles, if that is in the division, that will get subtracted. If you will subtract 53.13 minus 53.13, that will be 0. So 80 times times j 80, right? That means 80 with the angle of 90 degree volt. Okay, that will be the voltage across this inductor. Now then what will be the voltage? The V Thevenin will be how much? So V Thevenin will be how much? 80 degree times 10, right? So 10. This will be the V Thevenin. Anyone faced any issue in this?
How do
Yeah,
you
how did I?
get 90 degree and
Okay, 90
reverse?
degree. Yeah. So okay, let's solve it again. So while solving this, so we have to calculate the voltage across inductor, right? So while if let's for example you just think of as this is not an inductor because we can just think of as just some impedance, okay? So with the like some impedance value was J 4 ohm, okay? So now we have to calculate the voltage across that particular uh, inductor, right? So how do you calculate with the voltage divider rule? The voltage across this upon the total resistance in this circuit itself. So 3 ohm plus 4J. So now we have written in the form of this was in the polar form. So we'll try to write this also in the polar form. So if we'll write it in the polar form, we'll be left with 100 times 53.13 upon this. If you'll calculate this, you can write it in form of what? Magnitude and angle. Correct? So magnitude is what? Under root of 3 square plus 4 square. So 5. And angle, if you'll calculate it, it will be tan inverse of 4 upon 3. Okay, that is also 53.15 times J4. J4 ohm. J4 ohm you can write it or you can write it as 4 times 90 degree. Correct? J, if there is a J, you can just write it as 90 degree, like that is a lead of 90 degree. Now if you'll just
Yes,
write
sir.
it 5 will get cut, and this 53 angle, if you'll just write it 50 20 times 4, and angle if you write 53.13, because angle if it is multiplication it will get added, and if it is in division it will subtract it. So this is also 53.13. Okay, so this will get cancelled, so you'll be left with 80 times 90. Okay, is this fine now?
Yes, sir. Yes, sir. Fine.
Okay, so this is the value across the inductor, and now if you multiply 10 times you'll get the voltage Thevenin. Is it fine for everyone? Can we move to the next problem? Okay, yeah, this is the next question, where what you have to do is you have to calculate the G Thevenin across PQ. So across this PQ, you have to calculate the Thevenin, the impedance Thevenin, Z Thevenin, okay, or G Thevenin you have to calculate. Okay, so how will you calculate? You can see that you just have this is also what? This is independent source. What else? This is also independent source. Now, whenever you have an independent source, that means case one. Case one was what? You have to calculate R Thevenin equals to or G Thevenin equals to what? R equivalent, and all the independent source you can put it as 0. Correct? When you'll put independent source as 0, this will get short circuited and this will get open circuit. This will be open and this will be short, because I if you are putting as 0 that will be open, and voltage if you are putting as 0 that will be short circuit. Okay, so this will be short circuited and this will be open. So if you'll just open, and then you have to calculate the G Thevenin or the G equivalent from here. Are you able to understand this or not?
Yes, sir.
Yes, sir.
Okay. Okay. So if you have to calculate the impedance across this, one more thing you have to do, right? This you have to write it in the form of what? And this also you have to write it in the form of impedance, like in the form of J, right? So what will be the value here? J XL, right? J omega L. L is 1. So you can write omega was not given, so that's fine. Because in the end it will get cancelled. Omega. So now here also will be what? Minus J upon omega. C is 1. Correct? L also is 1. So this will be the, so you can just think of as J omega ohm and minus J upon omega ohm. Clear? Now can you tell me whether these are all in the this is also 1 ohm, so you can think this is an open circuit. Now if this is an open circuit, if you have to see from here, right, this will be in series, this will be in series, and this both will be in what? Parallel. Correct? Are you able to understand this?
Yes,
Yes,
sir.
sir.
Right, so now if these are two in series, the value will be what? 1 plus j omega. And if these two are in series, the value will be 1 minus j upon omega. Correct? And this G1 and G2 are in parallel to each other. So if they are parallel to each other, G equivalent will be what? J1 parallel to J2. So, so this will be 1 plus j omega, 1 plus j omega times 1 minus j by omega upon 1 plus j omega plus, if you just multiply 1 minus j omega by omega plus j omega, and this minus j square, omega omega will get cancelled. So this will be j square is what? What is the value of j square?
Minus
-1.
Minus 1, right? So minus 1 minus, so it will become plus 1. Correct? This will be plus 1. And then in the denominator part also you will see that 1 minus j upon omega are both same, right? So this will get cancelled. This will be 1. Is it clear now?
Yes, sir.
Okay. So now this is the one question. Okay, one more thing. Whenever in your circuit you just have a resistance in the load, okay, and in the whole circuit you just have a resistance, then calculating using maximum power theory becomes very simple, right? You just have to do out the equivalent circuit that you are making. In that equivalent circuit, the load resistance should be equals to your R Thevenin, right? Then the maximum power will get dissipated through your load resistance. Correct? This is what happened when you just in the whole circuit you just have a resistance, and in the load also you just have the resistance. But when in the whole circuit you have a mix of resistance, inductor and capacitor, okay, then you'll be having both real and the imaginary part, right? So your impedance will be in the form of R plus jx. Correct? So in those cases, if you have to calculate the maximum power dissipation across the load, then you can have other like different types of cases, right? What are the cases that you can think of? So the first case one can be, let's for example, in the whole circuit you have, so this is in the circuit and this is in the load. So in the circuit you have, so in the circuit will be R plus jx, and the load, so rs I'm writing rl plus j xl. Now you can think of in the load terminal you have been given that RL is only varying, so they can give, right, RL is only varying, XL is fixed, or they can give XL is varying, RL is fixed, right, or both are varying. Are you able to understand what I'm trying to say?
Yes, sir.
Correct. See, like in this example, in this question, you can see that in the whole circuit you were having resistance, inductor, correct, and in the load across which they are asking you where the maximum power will dissipate across that load. In that load also you were having a capacitor and a resistance, but they have been given that the resistance value is only varying, the capacitor value is fixed. Now you have to tell me what will be the value of RL such that the maximum power will get dissipated across this two, like the whole load. So this itself is a load, resistance plus capacitive, but capacitor value is fixed. Only the resistance is getting varied. Okay. There can be other question also where RL was fixed, the capacitor value was varying. So XC was varying. Or there can be a possibility where both are varying, right? This all can be a possibility, correct or not? Are you able to understand this or not? How
Yes,
many of
sir.
you are able to get it?
Yes, sir.
Yeah. So any doubt, you can just let me know that you're facing. If you're not able to understand this, I'll just reiterate it.
Sir, please explain again.
Okay. What I'm trying to say, see, you can have a circuit, right, where you can have a resistance plus the other thing, like the inductor or the capacitor, right? So your whole inductance will be in the form of real plus imaginary part, right? So Rs plus Jxc.
Yes, sir.
Okay. Okay. Now in the load also you can have a capacitor, inductor, resistance, right? So
Yes,
load also, the value can be RL plus JXL, correct? And now I can, like, there can be question, right, where only RL is varying. Let's, for example, in the first case where RL is only varying, XL is fixed. Now you have to tell me at what particular value of RL the maximum power dissipation will happen, maximum power theory. So where, what is the value of RL? Okay, this can be one problem. Second can be RL is fixed, but only XL is varying. This is varying. Now you have to tell me what will be the value of XL, such that the maximum power will get dissipated through this whole load. Okay, the third case can be where both RL and the XL both are varying, and now you have to tell me what is the value of ZL, such that the maximum power will get dissipated through your load. Did you get the idea what
yes,
I'm trying to say? So
yes, sir.
see, what is the for this case? This is, yeah, correct. So this is which one case? Case one, case two, or case three?
This is case one, sir.
Case one, correct. Because only RL is varying, other part are fixed. Okay, so I'm not going to derive here, but even though we can derive it, like in the same way our prof has derived, you just have to calculate the power. Okay, calculate and then differentiate it with respect to whatever, like RL has been given, then differentiate it with respect to RL, or differentiate it in the second case, differentiate it with respect to XL. Okay, in that way also you can solve it, but I'm just writing you the final value. What should be the value of RL? Okay, or there are other, is there any other cases also, possibility of any other cases? No. Okay, so yeah, so in the first case, you, that one thing you already know, right? When I guess the third case you already know, where ZL like if both of them are varying, right, then ZL should be equals to what? ZS, the conjugate, right? This case you already know, I hope. The first case, in first case where only RL is varying, you can directly write it as RS whole square plus XC plus XL whole square. Okay, and in the cases where XL is varying, okay, in that case for maximum MPT, this should be equal to minus of XC. And in the third case, you already know that when both are varying, then this should be equals to ZS conjugate. Okay, this is how you solve. So at this particular, if you are able to get the RL as this one, then the maximum power dissipation will happen through across that load. Okay, so in this case, now you have to solve this question. This is pretty simple question, where you can see that you have to calculate the maximum power dissipation across this load. Okay, so now what will be the value across this load? So what if you have to calculate across AB the Z Thevenin, what will be the value?
10 plus G10.
Correct, that will be the value, right? Now Z, is there any doubt while calculating the J Thevenin across AB? because what you'll do, this will be short circuited, right? Because you just have independent source, only one independent source, that will be short circuited if you have to calculate the Z Thevenin across AB, your load terminal, right, across AB, because both of them are coming under the load, right? One is fixed, one is variable. And I already told you, so Z Thevenin you have calculated Z10 plus J10. Okay, that will be omega. Now, if you have to calculate RL I told you, right? How to calculate RL? The formula is what? Whole square plus XL plus X whole square. So what will be the value? RL ka whole equals to XL 10. What is the value of X? Sorry, XS is, sorry, 15. Sorry, 10 only. Wait. No, this is, sorry. Okay, now you have to tell me what is the value of, this is what? What is the value of XL? XL is what? -5, right? Or if you are taking that, like, see, there can be two conditions. If you are taking XL minus XC, sorry, or you are taking minus XL the whole square. Okay, then in that case, your XL will become 15. But if you are taking XL plus XC ka whole square, then in that case, your XL will become -15. It depends on how you are taking, right? So if you are just taking as J times XC, okay, then your XC will be what? Minus of negative value, right? If you are taking minus JXC, in that case, your XC will be that positive value. Are you able to get it? So it's just the way how you represent. Both are correct. Okay.
Can you repeat, sir?
What I was trying to say, the formula to calculate RL is under root of RS square plus XL plus XC ka whole square. This representation can be different in some books or it can be other in the other books. You can just think of as many times if you just represent a capacitor like Z of XC, in that case XC will be what? Negative value. Like here if you'll just think of as JXC, then XC will be what? -15. But if you're just taking minus JXC, then your XC will be 15. It's just the way how you represent in the circuit. Okay, so for our case, whenever we are writing RL, you have to calculate RL. See, any case you can just think of as you have to take the difference between these two. And so that's why in many cases where XL is varying, you try to make it 0 such that you will just be left with the load resistance part only, the real part, right? To calculate the maximum power dissipation across that load, you want to just put this as less as possible, right? So that's why you can just think of as, if you are getting confused with that, whatever the difference that you are getting, that you will be writing here. Okay, that's why in the cases where XL is varying and RL is fixed, you try to put XL as same as XS, or the negative part, like however you represent it, so that this will get cancelled. Now you'll just be left with RL. Okay, that means what? If in the circuit you have an inductor, you try to put it a capacitor in the load such that both will get cancelled, and then you'll just be left with a resistance part, so that you'll be calculated, so that the maximum power will get dissipated. And if you have in the circuit you have a capacitor, you put an inductor in the load part, so that both of the imaginary part will get cancelled. Are you able to understand this or not?
Yes,
And I
sir.
guess this has been taught in the lectures also, right? Is this clear to everyone, or do I have to uh, explain it again? Is it clear, or shall I do it again?
From my side, it's okay, sir.
Is it clear to everyone? So have you understood this? So what maximum power dissipation, if you have a capacitor and inductor both, then in those cases you try to cancel the imaginary part somehow. Okay, if you just have RL is varying, right, XL is already fixed, then in those cases you can't do, then you have to calculate the this, use this formula. But if you have XL is varying, then what will you do? XL should be negative. Like if it's a, in the circuit, if it's an inductor, you try to put a capacitor in the load, or if it's capacitor in the circuit, you put inductor in the load, right? So that the imaginary part will get cancelled, and then you will be just left with the real part, and you can calculate the maximum dissipation across that load. Is it clear to everyone? Can we move to the next part?
Yes.
Okay. Now, then this is the next question. Now, for this case, you have to calculate the V Thevenin and R Thevenin. I already told you something, right? So V Thevenin, can somebody tell me just without even touching the pane? What will be the value of V Thevenin? You can see that you don't have any independent source. You just have the dependent source, right? So what will be the value of V Thevenin? V
Zero.
Thevenin is always a 0, correct? Because V Thevenin is always a function of independent source. V Thevenin is a function of independent source. Here you can see that you don't have any independent source. So if you don't have any independent source, then directly the value will become 0 volt. Now we will just be having R Thevenin. Is it clear? In the starting of the lecture itself, I told you, right? Okay. Now, how will you calculate R Thevenin? So if you just have a dependent source, case 3, right? See, I note you in the starting itself, I told you there are 3 cases, right? The first case is where only independent sources are there. Then you calculate R Thevenin as R equivalent, all the independent sources as 0, and V Thevenin is V open circuit. Second case, mix of independent dependent, case 2, where you calculate R Thevenin as VDC upon IDC. VDC, you just take it as a voltage across the load resistance, and you pass a current IDC. Okay, and V Thevenin will be. In the third case, you just have a dependent source. If you just have a dependent source, then in those cases, V Thevenin will pakka 0, because V Thevenin is a function of independent source. So the value will be 0. Now R Thevenin you have to calculate V DC upon IDC. VDC, you just take a voltage source across the load terminal and then pass a current IDC, and then you calculate the V upon I. That will be the value of R. Is it clear to everyone? Is it clear now?
Yes, sir.
Yes, sir.
Okay. Now you have to calculate the RTH. So case 3, right? How do we calculate RTH? RTH is BDC. The VDC here. So you can just take a voltage, add a VDC here, and pass it. Okay, you don't have to touch anything here because you don't have any independent source. You just have a dependent source. The voltage, this is what? A voltage. This is a voltage source, right? Voltage controlled voltage source, right? The voltage, this voltage is controlled by the voltage across this 5 ohm resistance. Is it clear?
Yes, sir.
Let's try to solve it. So this is IDC, correct? Take a current I passing through this 15 ohm resistance. So the left current will be passing in this circuit. There will be IDC minus I. Okay. Let's use KVL in this circuit. Okay, this loop, let's use KVL. Okay. Now, if you use it, I'll just copy it from here. See, at the end, we need VDC upon IDC to get the R Thevenin, right? So let's try to solve it. So in the first loop, we'll try to use the KVL here. If we'll try to use the KVL, you can see that the voltage. So we are just going from here like this, and then coming here, and then again going here, right? So the voltage drop in the whole this loop will be 0, right? So you can use KVL. Now minus 4 V naught, correct? This is what? Plus minus, because the current is passing through, and this is also plus minus, so this is 9. So plus 10 times IDC, what will be the value? So current is passing like this, right? So 15 I. So here, but as we are moving in this direction, it will be minus 15 times I equals to 0. So this is the first equation you can think of. Correct? Okay. One more thing. This V naught, what will be the value of V naught? Can somebody tell me what is the drop across this 5 ohm? I times resistance. What is the I passing through this 5 ohm? IDC
Minus I.
minus I times 5. Correct? So everywhere we correct. So IDC minus I, we can just replace it. IDC minus I times 5, we can replace it as V naught. So this equation, I can use the help of the second equation. So minus 4 times V naught plus 2 times V naught equals to 15I. Okay. Now we can use in this loop also. If you'll just use in this loop, the second loop, what will the value we'll be getting? This is pretty simple, right? There is only one source and one resistance. So minus VDC. So if we'll just use it, minus VDC plus 15I equals to 0. So VDC is what? 15I. Not okay. To calculate RThevenin, what do you need? VDC comma VDC. Correct? Is this clear?
Yes, sir.
Okay. Now you need IDC. So what you can try it out? We were having this equation, right? So what was that equation? I'll just add one space. Okay. So I was having V naught equals to what? 5 times IDC minus I. Now IDC form, because RTH is what? VDC upon IDC. So I can write it as IDC minus 5 times I. Is there any equation where, okay, you can see that, right? I is what? VDC upon 15. Now you can write it as. So now the whole equation got converted. So I can write it as what? I equals to VDC upon 15. 3. So now you can see that this will, you can just move it here. So minus VDC plus VDC upon 3 IDC. So VDC upon IDC is what? 5 times 3, 0.5 ohm. So do not get confused. How can I get a resistance negative value of the resistance? Okay. So in the exam also, if you are getting, whenever you are calculating for any circuit, the R equivalent coming out to be minus 7 in the negative value, then there can be only one possibility, that you are dealing with a circuit where there were some independent source also. So whenever there is some dependent source, then that whole circuit can work as a active, like, see what happens, resistance and all is what? Passive network, right? Passive thing that generally needs energy, like all the energy gets dissipated in like the resistance, right? But it can also work as an active circuit when you have some of the sources that are dependent source. Okay, so whenever, one thing that should be there in your mind, whenever you are solving any Thevenin, if you are getting R Thevenin as 0 or a negative value, that is quite possible. This is not a resistance of a particular resistor. Okay, this is just a R equivalent for a circuit where you are dealing with a dependent sources. So whenever you are calculating the R Thevenin of a circuit where some of the sources are dependent, in those cases you can get R equivalent as 0 or negative value also. Is that clear to everyone?
Sir, then we have to write minus 7.5 ohm as result.
Yeah, correct. Minus 7.5 as a result. This is not a resistance of a particular resistor. This is just the resistance equivalent, okay,
Okay.
Z or R equivalent for a circuit that is working as an active case. Okay, mostly whenever what we are dealing with resistance, okay, like a voltage source that gives a voltage, like gives the energy, right? Resistance generally takes the, like the energy get dissipated across the resistance, right? Okay, so but whenever you're dealing with a case or a circuit where some of the sources are dependent, in those cases this is quite possible where you can get a equivalent circuit, the resistance R equivalent or RTH can be 0 or minus negative also. So in the exam also, if you have been asked if you are getting negative value, do not get confused that my answer is wrong, because it is quite possible for a circuit where, but you have to check like whether the circuit that I am dealing with, is this a circuit with an independent dependent source. If there are dependent source, then the negative value is quite possible, and it will happen when you will practice more and more question. You'll see that many a times. I guess in the previous session also, there in the last, I guess last question, if you'll see, the R value that we were getting was a negative -1. Okay, that was also a case where we were calculating the Thevenin resistance, and that was negative because that circuit was also was giving energy, right, or the power. Is this clear to everyone?
Yes, sir.
Yes, sir.
Clear, right? So R can be negative and 0 also. So this is quite possible. Okay. Now our next case. Now you have to calculate the R across AB. I'm not going to solve. You just try it out. I'm just giving you 2 minutes, and then tell me the value of R across the AB. This is very simple. One dependent source, one independent. I'll just tell you this is what case 2, where you have to calculate R Thevenin as VDC. Only one independent source, just short circuited. So after this, you'll get short circuited, right? Now you have pretty simple circuit. Okay. Now you have to calculate R Thevenin. Once you will short circuit, you just need Ix. If you need if you will having Ix, then you can get the value of the voltage across this. Voltage like Ix will only give you an idea that what will be the value of Thevenin. So we first calculate the Ix, short circuit this, and calculate, use the loop like KVL in any of the circuit, okay, or maybe in the bigger circuit itself. If you use it, you will get the value of Ix. Okay, so I'll just give you a hint also. You just have to short circuit this, short circuited. Now add a VDC, and the current passing is IDC. You have to calculate V of VDC upon IDC. So you can use KVL here in the loop 1 or here also. You'll get the, in the first case you'll get the value of Ix, and then you can use the value of Ix here to get the value of VDC upon IDC. Just use it. So if you are using KVL here, what is the value that you are getting? See, what will be the value? Ix. So you just use it. This will be plus minus So this will be what? Ix times 1 kilo ohm, correct? Plus 1000 Ix equals to 0, right? Are you able to hear me or not? Am I
Yes.
audible?
Yes, sir.
Okay. Okay. So Ix is 0. If Ix is 0, now use it in this circuit. So if Ix is 0, this is what drop is what. So there is a gain of, if you'll just take it VDC, okay, and then equals to 1000 Ix. This is what? This is 0. So VDC is what? Can get an idea, right? There can be a circuit where, but only one thing is there should be dependent source. Okay, some dependent source should be there. Then in those cases, your equivalent circuit, the resistance can be 0 also. It can be negative also. We have dealt with many cases where the value was positive. Now we have dealt with some cases where the value is negative also, and some cases where the value can be 0 also. Okay, so everything is possible. But you don't get confused that how can a resistance value will be 0. This is not, we are talking about any particular thing, any particular resistor where the value of resistance is 0. We are just talking that equivalent circuit resistance is coming out to be 0 because there were some dependent sources in that. Clear?
Yes, sir.
Yes, sir. Yes, sir. Clear.
Okay. Now the next problem that you have to solve is this one. Here also you have to calculate RTH across AB. So here also you have some independent source, you have dependent source. So again, independent plus dependent source. So second case, you can use it. Case 2, where what RThevenin you have to use it as what? Dependent IDC. So no current in this circuit. So this becomes very simple, right? You just have one loop, correct? So here IDC is what? IDC become your IX, correct? So this becomes very simple. Now if we'll just use it in the KVL in this circuit, what will be the value? Minus of VDC plus minus, there is a drop of what? Not drop, gain, whatever you want to call it as IDC times 2, then plus 3 times IX or IDC, because both are same. And then again here you can just write it as plus times plus minus,
Answer 15, sir. I think.
now in IDC,
Sir,
what
your
you have to
voice
do?
is breaking sometime.
Oh, is it breaking?
Yes, sir.
Oh, okay. Okay, might be some. Is it clear now, or is it breaking now also?
Yes, clear, sir.
Okay. Okay. So have you tried it? Solved it? This 15 ohm. Yeah, 15 ohm is correct. I solved it, right? So this you have to just open because you were having a current source, open circuit. So you are just left with one circuit. So Ix will become same as IDC. Now you can use a KVL in the circuit. You'll get the value of VDC upon IDC. Any doubt in this question? Anyone?
No, sir.
Okay. You want to try some more questions or this is done? Like, if you want to solve, so this question also you can try it out, where you have to calculate the maximum power across R. So if you have to calculate that, what do you need? What are the steps that you should be following? What is the first step? What do you need to calculate the maximum power? What is the formula?
R Thevenin. First of all,
V
we
Thevenin upon 4 times R Thevenin. So you need V Thevenin and R Thevenin both. Both. Yeah, yeah. Go ahead. Okay. So for R Thevenin, what will you do? This is my voice clear?
No, sir. Sometime breaking.
Okay, might be some internet issue. I'll try to connect it from a different Wi-Fi. Are you guys able to hear me now?
Yes, sir.
So yeah. So now in this case, this is very simple. This is I guess you can what you can do is how will you calculate the RThevenin? This will be short circuited, right? This will also be short circuited. This will also be short circuited. Correct? Short circuit, and you have to calculate the resistance from here. Parallel to 2 kilo ohm. Clear? Uh, are you guys there? Able to hear me? Are you guys able to hear me? Can somebody, or if it's breaking a lot, then hello, anyone there?
Yes, sir.
Okay. Is it breaking a lot? The voice?
No,
No,
sir.
sir. No, no, sir.
Okay. R equivalent is coming out to be 1 kilo ohm, right? This everyone got it?
Yes, sir.
Okay. So now for this you need to calculate the V Thevenin also, right? How will you calculate V Thevenin? V Thevenin same, right? See, how will you calculate V Thevenin? In this circuit itself, you were having what? Okay, I'll just. So here you have to calculate V Thevenin across here. So this you have to calculate V of open circuit. The current will be I will be 0. So if you just able to calculate VA here, right? So VOC will be what? VA plus again. Correct? How can you calculate VA here?
By KCL.
Calculating current.
Yeah. Yeah. So how will you do that? VA
Minus 20 by 2.
minus 20 by 2
plus VA minus 30 by 2.
plus VA minus 30 by 2. This, if you are taking 30, then minus 30 you are taking, then here it should be plus 20. Correct? And then you can put it as 0. Now, what will be the value of VA that you are getting? So, it will be what?
10.
VA equals
So
to
your
10.
voice
Okay?
is
So,
breaking.
VA will be 5. Correct? So, we got for 4. Yeah. Yeah. So, yeah, my Wi Fi is not working. I have connected from mobile data. I guess it's not working properly, but I don't know what to do. But yeah, so this was the last question. I hope if the voice is not that good,
It's
then
okay, sir.
we'll try to solve it, this question, in the coming session. But as of now, I'll try to upload all the seats that we are discussing on the portal. So is the seat uploaded for the last previous session that we have taken? All the other session, I guess 6, 7, 6. This is the sixth session that I'm taking. Is the all slides uploaded on the portal, on the supplementary content, somewhere in the live session slides? Because I have already given it to the ops team. I don't know whether it's uploaded or not. So if it's not uploaded, please let me know. If it's uploaded also, you can let me know on the Discord or anywhere. Okay. So this power you can calculate
Sir,
it, and yeah.
practice assignment week 3 is not opening. Given
Not
in the supplementary, but there is some issue. Week 1
okay.
and 2 practice is opening, but 3 is not opening.
Oh, practice solution or practice.
Solution, practice solution.
Okay, okay. Then I'll check that. I'll check that, and maybe by today it will be done.
Okay, sir.
Okay. So is this question everybody able to understand this, right? You can calculate the power, right?
Sir.
Okay. So this was it. Like I've tried to solve delta to star and all. You can just solve it. It is just one formula. It's not that important also, but you should be knowing in any, not be particularly asked, but in any of the circuit, if you can take the help of the delta to star to delta, that'll be. But particularly that won't be asked like. Okay. Yeah. So this was it for. So have you understood the concept that we have discussed?
Yes, sir.
That will help you in the paper also to solve it. So there will be some two comprehension that will be totally based on Thevenin and like what we have discussed. Okay, most of the problem will be similar to what we have discussed till now. Okay, the next week content is totally on the, I guess, Laplace. That is also pretty simple. So yeah, and before the exam also we'll try to do a revision session or something where we'll just try to solve the question itself, some 20-30 questions. That will help you a lot in the. I'll try to get an idea from the paper and then try to solve as many as questions, so that we'll directly be able to solve it. So that is the conceptual part. It should be clear so that we can try to solve it out some 20-30 questions before the exam also. I guess 23rd is the exam. We'll try to do it in the last week of the paper itself. Okay, from the whole 4 weeks. Those I think there can be there's a chance to have some questions. Okay, so yeah, this is done for the today. We'll meet again in the coming week. So, are you able to
Thank you.
understand this? Is the uh, are you able to understand this? Is the session helpful? Or is it helping you to solve the questions or not?
Yes, sir.
Yes,
Very
sir.
much helpful to us.
Yes, sir. It is helpful.
Oh, okay then. Have a good day. We'll meet again in the next week. Thanks everyone.
Thank you,
Confirming
sir.
that.
Okay, sir.
Thank you, sir.
Okay.